Hello everyone, my name is Mark Lewis and my matrix number is 75558. I'm currently taking Mechanical and Manufacturing Engineering in University Malaysia Sarawak. In this video, I will briefly explain about thermodynamics and its application. Hope you enjoy. Before we move on to the application of thermodynamics, firstly, I would like to explain a little about thermodynamics. Thermodynamics can be defined as the science of energy. The name thermodynamics itself originates from the Greek words therm, which means heat, and dynamis, which means power. These are the law of thermodynamics. Conservation of energy principle states that during an interaction, energy can change from one form to another, but the total energy remains constant. The first law of thermodynamics states that the expression of the conservation of energy principle and asserts that energy is a thermodynamic property. The first law also states that energy cannot be created or destroyed, it can only change form. The second law of thermodynamics asserts that energy has quality as well as quantity, and actual processes occur in the direction of decreasing quality of energy. Now, let us look at the example of conservation of energy. A person who has greater energy input, which is food, than energy output, which is exercise, will gain weight. This means that the excess energy is stored in the form of fat. While a person who has a smaller energy input than output will lose weight. The change in energy content of a body or any other system is equal to the difference between the energy input and the energy output. Next, we will look at the example of second law of thermodynamics. A cup of hot coffee left on the table eventually cools, but a cup of cool coffee in the same room never gets hot by itself. The high temperature and energy of a coffee is degraded once it is transferred to the surrounding air, which means it transforms into a less useful form at a lower temperature. There are two types of study of thermodynamics. The first one is classical thermodynamics. Classical thermodynamics is a macroscopic approach to the study of thermodynamics that does not require a knowledge of the behavior of individual particles. It provides a direct and easy way to the solution of engineering problems. The second type of study of thermodynamics is statistical thermodynamics. Statistical thermodynamics is a macroscopic approach based on the average behavior of large groups of individual particles. Now, we will look at the application of thermodynamics in our daily lives. All activities in nature involve some interaction between energy and matters. Thus, it is hard to imagine an area that does not relate to thermodynamics in some manner. So, this is a refrigerator. What is the law applied in a refrigerator system? The law which is applied in refrigerator system is the second law of thermodynamics. According to the second law of thermodynamics, heat will always flow voluntarily from hot to cold, and never the other way around. A refrigerator causes heat to flow from cold to hot by inputting work, which cools the space inside of the refrigerator. So here we will look at the basic vapor compression cycle and components. The first one is the compressor. The second one is the condenser. The third, expansion valve, and last but not least, the evaporator. Okay, so this right here is the compressor. The compressor is the pump that enables the flow of refrigerant. The compressor works by increasing the pressure and temperature of the vaporized refrigerant. There are different types of compressors for refrigeration application. Reciprocating, rotary, and centrifugal compressor are the most common among refrigeration unit. Okay, so this is a condenser. The condenser is a set of coiled tubes. In the domestic refrigerator, you will find your condenser at the back of the appliance. The condenser cools the vaporized refrigerant, turning it back to liquid. Okay, moving on. This is the expansion valve. This device controls the flow of the liquid refrigerant. The expansion valve is thermostatic, so it responds to the temperature that you set. Okay, so this is the evaporator. The evaporator is the cooling component of the refrigeration system. It absorbs heat from the contents within the cooling appliance. In the domestic refrigerator, the evaporator is in your freezing compartment, which is this compartment. Now I will go through briefly about the refrigerant cycle. Firstly, the refrigerant flows from the evaporator coil through the compressor. This flow will raise the pressure of the coolant. Then, the vaporized refrigerant then flows to the condenser where it transforms to liquid. As the refrigerant condenses to a liquid, it gives off heat. This explains why the condenser or the back of refrigerator is relatively hot when you touch it. Then, from the condenser, the refrigerant flows to the expansion valve. There is a drop of pressure in the expansion valve. From the expansion valve, the refrigerant flows to the evaporator. The liquid refrigerant draws heat from the evaporator environment. This heat vaporizes the liquid refrigerant. Last but not least, the vaporized refrigerant flows back to the compressor where the cycle continues.